Welcome! So today's explainer has a pretty wild premise, actually. We are going to compare two massive, highly volatile, and, well, totally different entities that just happen to share the exact same name. We're putting a celestial heavyweight side by side with a cultural heavyweight. And as you'll see, their life cycles, their eruptions, and their overall impacts actually mirror each other in some incredibly unexpected ways. Now, you might be wondering, what does a 4.6 billion-year-old star have in common with a British tabloid? I know, it sounds like the setup to a strange joke, right? Like, how could astrophysics and British media history possibly intersect? Well, both of these suns have incredibly explosive origins. They both go through periods of intense volatility that affect literally everything in their orbit. And crucially, they both have to evolve to survive. Okay, let's dive into this. Here is our roadmap for today. We'll be looking at 1. Origins and evolutions. 2. Eruptions and controversies. 3. Tracking the impact. And finally, 4. Forecasting the future. Section 1. Origins and evolutions. How they started. And this brilliantly illustrates just how staggering the contrast in scale really is. Our celestial sun is roughly 4.6 billion years old, born from the gravitational collapse of a giant molecular cloud out in deep space. Meanwhile, the Sun newspaper is roughly 60 years old, relaunched in 1964 from the ashes of a totally different publication called the Daily Herald. So you've got one birth triggered by the immense physical shockwave of a supernova, and the other triggered by the intense commercial pressures of the 1960s British media market. For the star, the literal origin is explained by something called the nebular hypothesis. About 4.6 billion years ago, a fragment of a massive molecular cloud, kind of like what we see today in stellar nurseries like the Orion Nebula, started to collapse. And scientists have actually found traces of iron-60 in ancient meteorites, which tells us that a nearby supernova likely provided the exact shockwave needed to trigger this collapse. So most of that mass, which was mostly hydrogen and helium, collected right in the center, building up just unimaginable pressure until nuclear fusion ignited. And boom, just like that, our sun was born. Let's move to and see how this builds into the earthly sun, where the ignition pressure wasn't gravitational at all, it was completely economic. The paper actually started way back in 1911 as the Daily Herald, which was the left-wing paper supporting striking workers. But by 1964, the Trades Union Congress sold its remaining shares, and it was relaunched as a broadsheet called The Sun. The true ignition moment, though, that happened in 1969 when Rupert Murdoch acquired it. He flipped it into a tabloid format, slapped on that bold red and white masthead, and basically launched a media empire that just kept expanding, even adding a Sunday edition in 2012. Moving into Section 2, Eruptions and Controversies, How they operate. So we can actually objectively measure the volatility of our celestial sun using real space weather data from SANSA. You see, our star isn't just some quiet ball of gas hanging out in space. It has a highly dynamic surface. We track solar wind speeds clocking in between 350 and 430 kilometers per second. It has these super active sunspot regions with incredibly complex magnetic configurations, and it frequently fires off B-class X-ray flares. When these eruptions, like coronal mass ejections, actually hit Earth, they create geomagnetic conditions that directly mess with our high-frequency communications. It is a constant, measurable output of energy that literally alters the environment around it. In a very similar vein, the tabloid sun creates its own environmental shifts, just specifically within the political landscape of the UK. Much like how the celestial sun has a magnetic cycle that flips, the newspaper has historically shifted its political allegiances to align with changing times. It originally stemmed from a pro-union paper, right? But then it made this massive, sensational shift to back conservative leader Margaret Thatcher in 1978. It kept that backing for John Major in 1992, but then flipped its magnetic poles all over again to support the center-left Labour Party under Tony Blair in 1997. It's a very clear record of objective historical shifts by a highly influential publication. Now, what's really interesting about this next point is the famous 1992 headline, "It's the Sun what won it." They claim direct credit for helping John Major win the general election. And, regardless of how much quantifiable impact the paper actually had on the ballot box itself, this statement perfectly captures the paper's perceived cultural gravity. Much like our star pulls planets into its orbit, the tabloid clearly views itself as this central, gravitational force capable of pulling public opinion and political outcomes right in its direction. But, as we know, sensational eruptions can also cause some permanent damage. Back in 1989, right after the tragic Hillsborough football stadium disaster, The Sun published highly controversial and very negative claims about Liverpool fans. The fallout from this sensationalist journalism was immediate, and it was devastating for the paper. It sparked a massive citywide boycott in Liverpool, causing a 75% plunge in local sales. And honestly, it was a blow that the newspaper's regional readership never fully recovered from. It's a pretty stark reminder of the destructive potential of unchecked volatility. Section 3. Tracking the impact, the numbers. So the crucial point here is the number 423.2 kilometers per second. That is a specific solar wind speed recently measured by the SANSA Space Weather Bulletin. Just think about that speed for a second. That is the sheer physical force our star outputs every single day, just sweeping across the entire solar system, interacting with Earth's magnetic field, and causing everything from those gorgeous auroras we see to major satellite disruptions. It's just this constant, unrelenting physical force. Now contrast that constant cosmic output with the newspaper's print circulation. While the star remains incredibly steady, the printed tabloid has seen a pretty dramatic decline. Think about their peak back in 1987. They were selling nearly 4 million copies every single day. By 2010, that number had dropped by a solid million. And by 2020, print circulation had shrunk down to roughly 1.2 million. If we were only looking at physical paper copies, you'd probably think this media star is burning out fast. But actually, scratch that. A declining print circulation doesn't mean the entity itself is disappearing. 33.9 million. That massive number represents the newspaper's record-breaking unique digital visitors in July of 2019 alone. In fact, right around that time, it actually overtook its rivals to become the largest online news brand in the UK. So the paper didn't just fade away. It simply transformed its medium. It evolved its reach to survive in a totally new digital environment. And that brings us to Section 4, forecasting the future. What happens next? For the celestial sun, its ultimate future is literally written in the laws of physics. In roughly 5 billion years, the hydrogen fusion happening in the sun's core will just stop. As its surface cools down, it's going to first expand into a subgiant and then swell up massively into a red giant, which, by the way, will swallow the inner planets entirely. Eventually, it'll cast off its outer layers to create the stunning cloud of gas called a planetary nebula. And what's left behind is just the core, a super dense, glowing remnant known as a white dwarf. Over tens of billions of years, it'll just slowly cool off, all alone in interstellar space. But here's the thing. While the celestial sun's timeline is mapped out in billions of years and is basically guaranteed to outlive us all as a white dwarf, human media is incredibly fragile. We've watched a paper evolve from a 1911 broadsheet into a modern digital giant, but it really makes you wonder, how long can human media institutions actually survive in the digital age? What will our cultural landscape look like even just a century from now? Thanks so much for joining me for today's Explainer, guys. See you next time.